Those, sorry. Those of you on the Zoom, can you start doing question number 3 on problem sheet 6, which you don't have a copy, is on the course website. I just written down what the question is to find var and es if x is a variable, if x is a uniform variable on the interval from a to b. Right, I'll give you a few minutes, see if you can do it. Not many people coming.
I think it could be something that you can analyze in this.
It's also called power law, and it's also called zip law. Z-I-P-F. Z-I-P-F. Come on, that's the formula. So you know, search those terms. All right, guys. You guys done this? This is trivial, right? I mean, there's no. So as I did I did several examples on Wednesday. I did several examples on Wednesday, so this should be trivial for you guys. So what you do is you set to find the var, you set the CDF equal to P and solve for X. The CDF of a uniform variable so X is equal to B plus, sorry, this is A. This is A, not. Alright, so this implies that var okay, now to find the expected shortfall, you do this, yeah? So you integrate, so 1 over P times A T plus B minus A T squared integrated T squared by 2 integrated from 0 to P, you get 1 over P AP plus B minus A P squared minus 0. Okay, so it becomes all right, guys. So this is trivial. It should be trivial for you guys. So it's the answer for question number 3. The next question on the sheet is Pareto. So I'll write it down. So question number 3 done. This is the Pareto type 1 distribution where X is greater than K is positive and A is also positive. Alright, I'll give you a few minutes, you can do this. Well, please, also guys in the Zoom, please do this question, guys. If you get stuck, let me know. Okay. All right, guys, had you done this? All right, let me show you. This is also trivial. So to find the var, set this to p. So this becomes so x is equal to k times this, so this is your var. So your var is okay. Now to find the expected shortfall, integrate with respect to t. Here you have to be a little careful because it depends. Okay, I will explain in a minute. Right, I know this is not in the solution, but when a is equal to 1, what you have is 1 divided by 1 minus t, and the integral of that is log. So for the moment, let's assume that a is not equal to 1. Okay. So assuming that a is not equal to 1, the integration will be this. If a is not equal to 1. So if you take the limits, okay, let's take this outside. So this becomes k over 1 over a minus 1 here, and taking the limit at p, you get, taking the limit at p, you get 1 minus p, and taking the limit at 0, you get 1. All right, so here it's still, we are still assuming that a is not equal to 1. Okay. Now, if a is equal to 1, let's consider the case. If a is equal to 1, then this guy here will become one over 1 minus t dt, right? Okay, and the integral of this, I'm sure you guys know, is this, take the limits from 0 to p, and the limit at p will be minus log of 1 minus p, and the limit at 0 is 0, right? So this is what you have. So this is in the case if A is equal to 1, right? So in summary, you will write your answer for the expected shortfall will be the following, right? Will be two cases, yeah. So if A is not equal to 1, you have K times A times 1 minus A in brackets alright. This is if A is not equal to 1, and if A is equal to 1, then you have minus K. Or I left a P here? There should be a P, sorry. There should be a P here. Sorry guys for this. I left out a P. So this is what you have if A is equal to 1. Okay. Alright guys, are you okay with this? Any questions? Okay. Alright. The next question is number 5. We have done it already. Number 6, I'm not sure if we did it or not. Did we do number 6 in the class? No. All right. So let me take this away. Here we go. So this is question 6. One divided by x divided by a x is positive, a is positive and b is positive. Okay, can you take a few minutes and see if you can do this, please? All right, guys. So let's start with this. So to find var, once again, you just equal to p, which implies that this implies that so x over a is so x is a times p divided by 1 minus p to the power 1 over p. Alright, so this is your var, your value at risk is a p to the power 1 over b, 1 minus p power minus 1 over p. Now, to find the expected shortfall, okay. Now so here I'm going to use something that I talked about on Wednesday. I hope you guys you listened to me. Now this integral here is something that I talked about on Wednesday this week. Yeah? Do you remember what that integral is or no? Guys, hello. You guys remember this? It's known as the incomplete. I will write down one more time. It's known as the incomplete beta function, which arises as the CDF of a beta random variable, right? Is defined as, once again, the integral from 0 to x. X is the number between 0 and 1, t power alpha minus 1, 1 minus t power beta minus 1 dt. Right, so this is, let me put this in a box. Right, so this becomes a over p times the incomplete beta function at p. Alpha is 1 over b plus 1, and your beta is 1 minus 1 over b. Okay, guys. Are you okay with this or no? Anyone in Zoom, you have problems? All right, the next question is question number 7 on the problem sheet, which is a Lomax distribution. Lomax is also is a different name for Pareto type 2. So you have So this is, can I take this away? Okay, all right. This is question number 7. Right, X positive, alpha positive, lambda positive, right? And you take a few minutes and see if you can do this, guys. This is Alright guys, so let's see how we can do this. So set, as usual, set the CDF to P and solve for X to find the var. So this becomes 1 minus P. So this implies that 1 plus X by lambda is 1 minus P power minus 1 over alpha. Yeah. Okay, so X is gonna be lambda times alright, correct me if I'm wrong. Hopefully it's correct. So this is the formula for var. Now to find the expected shortfall, you just integrate this, so it becomes lambda by P times the integral of this guy here. Yeah. Now once again you need to consider two different cases for integration, because if alpha is 1, what you have here is 1 divided by 1 minus t, and which is integral is a log function. Okay, so let's first consider the case that alpha is not equal to 1. Yeah. So in this case this will become lambda by P yeah. Alright, and if you take the limits, you get the limit at P is gonna be yeah, and the limit at 0, the limit at 0 is gonna be, this is gonna be 1. So minus minus is plus, so it's the plus right. So this is what you get if lambda is, alpha is not equal to 1. Okay, is this okay? Check me, correct me if I'm wrong. Yeah. Now if alpha is equal to 1, so in this case alpha is equal to 1, right? Then you have lambda over P. The integral from 0 to P of that is gonna be minus log of 1 minus t, yeah, minus t, the limits from 0 to P. Yeah. So if you take the limit at P, you get minus log of 1 minus P minus P. Yeah. The limit at 0 is 0. Alright, so okay, is that right? Okay, so in summary, you should write your answer as follows. So when alpha is not equal to 1, alright, that's if alpha is not equal to 1, and if alpha is equal to 1, then you get alright guys, everybody okay? On the Zoom, are you guys okay? Any questions you guys have? Hello guys, talk to me on the Zoom. Are you okay guys? Alright, so you just have time for one more question, which is question 8. I'll just give it to you. You may want to think about this because it involves a special form of integration. So you may want to think about this. Is question number 8. Find sorry, what's that? Can't read it. This is fresh. Okay. Yeah. Alright, this involves a non-standard integration. You need to use some special function to work this out, especially the ES part of it. Okay, so think about it. Okay. So I know some of you might have done this already. But if you haven't done it, if you haven't done this question, think about it. We will talk about it next week. All the question 8 up to the last question, which is question 13. So question 8 to question 13, we will talk about it next week, same time. Yeah. And just a reminder that the quiz number 5 is due next Wednesday. So if you haven't done it already, please work on it. And be careful with your derivations, because quite a few people made mistakes with quiz 4. So please be, please be a little bit, try to be a little more careful with the derivations. Okay. All right, guys. So have a good weekend, and any questions, just feel free to contact me 24/7. Okay.
See you.